Understanding the OSI model, layers, security concerns, and mitigation strategies. The OSI, Open Systems Interconnection model, serves as a cornerstone in understanding how different systems communicate in a network. It establishes a universal framework for describing how information passes from one point to another. Mastering this model is essential not only for enhancing communication, but also for ensuring network security. This discussion delves into the OSI model, its 7 distinct layers, common security concerns associated with each, and practical mitigation strategies to safeguard against those concerns. By the end of this session, you'll gain actionable knowledge to develop and implement a robust layered security approach. The OSI model, developed by the International Organization for Standardization, is a conceptual framework used to standardize network communications. It is organized into 7 layers, each serving a unique role in transmitting data between systems. The OSI model is significant for 2 reasons. It breaks down complex networking systems into manageable layers, making troubleshooting and communication more efficient. It provides a structured approach to implement security strategies at each layer. Let's first explore these 7 layers briefly before diving into the associated security concerns. Layer 1, Physical Layer. The physical layer is the foundation of the OSI model. It deals with hardware components, including cables, switches, and physical devices, and focuses on transmitting raw data bits over physical media. This layer ensures data is transferred reliably from one node to another. It structures data into frames and deals with MAC, Media Access Control addresses for hardware recognition. Network layer. The network layer is responsible for data routing, addressing, and forwarding across multiple mediums using protocols such as Internet Protocol. Layer 4, TransportLayer. This layer ensures the reliable transmission of data. It focuses on end-to-end error recovery, flow control, and guarantees data is delivered without duplication or loss. Layer 5, Session Layer. The session layer establishes, manages, and terminates communication sessions between devices. Layer 6, Presentation Layer. It ensures data is translated into a format understandable by the application layer, handling encryption, compression, and data encoding. Layer 7, Application Layer. The top layer provides end-user services including browser interfaces or email applications. It facilitates direct user interaction with the underlying network. Now that we understand each layer, let's address the security challenges associated with them and how to combat those vulnerabilities. The physical layer faces risks of physical hardware damage or unauthorized access. Threats include cable tampering, device theft, and illegal connections to network ports. Mitigation strategies. Secure the physical environment, such as server rooms, with access control mechanisms like biometric locks or card-based authentication. Use surveillance systems to monitor hardware locations. Regularly inspect cables and physical connections for signs of tampering. Security concerns. This layer is vulnerable to attacks like MAC address spoofing, VLAN hopping, or ARP address resolution protocol poisoning, which could allow an attacker to access restricted parts of the network. Mitigation strategies. Enable port security by allowing only specific MAC addresses on ports. Configure VLANs properly and restrict inter-VLAN communication to authorized users. Use tools to monitor ARP traffic and detect anomalies. Security concerns. Attacks at this layer include IP spoofing, routing table manipulations, and denial of service DOS attacks aimed at disrupting or rerouting network traffic. Mitigation strategies. Deploy firewalls to filter and block unauthorized traffic. Use intrusion detection systems IDS or intrusion prevention systems IPS to identify and neutralize suspicious traffic. Secure routing protocols with authentication mechanisms and configure virtual private networks VPNs for secure communication. Security concerns. This layer is prone to port scanning, session hijacking, and attacks that compromise the integrity of transmitted data. Mitigation strategies. Secure communications using encryption protocols like TLS, TransportLayer security. Monitor network traffic and block unused or suspicious ports using a firewall. Apply rate limiting to protect against traffic overload caused by DOS attacks. Security concerns. Threats at this layer include session hijacking and fixation, where attackers gain unauthorized access to an ongoing communication session. Mitigation strategies. Use strong authentication protocols like multi-factor authentication, MFA, to verify user access. Terminate unused or inactive sessions automatically. Implement session tokens and refresh them regularly during communication to prevent fixation. Data encryption vulnerabilities could expose sensitive information. Poor implementation of secure communication protocols may lead to breaches. Mitigation strategies. Use robust encryption techniques for both transmitting and storing data. Validate data formats rigorously before processing to prevent injection attacks. Conduct regular penetration testing to ensure encryption protocols are up to date. Security concerns. Often targeted by malware, phishing attacks, and software exploits, this layer represents the interface directly accessible to users. Mitigation strategies. Follow secure coding practices to avoid application-level vulnerabilities like SQL injection or cross-site scripting, XSS. Update software and patches regularly to address potential exploits. Employ anti-malware and anti-phishing tools to detect malicious activities. Each layer adds a critical component to the network's overall security. However, real-world networks require a unified layered approach to maximize protection. The concept of layered security, or defense in depth, emphasizes the importance of securing every layer of the OSI model to guard against potential breaches effectively. Think of it as constructing multiple barriers. If one defense fails, another layer is ready to intercept the threat. Effective implementation of layered security includes installing redundant measures like firewalls combined with intrusion prevention systems, IPS. Regular audits to ensure configurations across layers remain aligned with security best practices. Maintaining situational awareness via continuous monitoring tools like Security Information and Event Management, SIEM. The layered approach ensures network integrity even when novel attack methods are developed, offering maximum defense across all OSI levels. To further understand the importance of layered defense, let's consider two real-world examples. In some organizations, attackers manipulate IP addresses to access restricted network zones. By implementing firewalls at the network layer, encrypted VPNs at the transport layer, and end-user authentication at the application layer, the attack chain can be broken successfully. Malware injection through software exploit. A targeted malware injects itself via a vulnerable web application. Applying secure coding to eliminate code vulnerabilities, application layer, validating encryption protocols, presentation layer, and using anti-malware solutions minimizes the damage. Such examples emphasize the importance of collective security measures across all layers. Each OSI layer has unique responsibilities and vulnerabilities, making it critical to understand the correlation between them. Here are the key takeaways. Physical layer, secure physical environments to prevent hardware tampering. Data link layer, control MAC addresses and monitor VLAN configurations. Network layer, use firewalls and VPNs to safeguard routing protocols. Transport layer, encrypt data and monitor port activity to guarantee safe communications. Session layer, protect session integrity with secure authentication and regular token updates. Enforce proper encryption and validate data formats comprehensively. Application layer, keep application software up to date and promote secure coding practices. By applying these principles, IT students can better manage and reduce risks in a networked environment. In today's rapidly evolving threat landscape, understanding the OSI model is no longer optional. It's a necessity. IT professionals must prioritize security at every OSI layer, implementing best practices for prevention, detection, and response. Equally important is the need for continuous learning. The threats networks face today may evolve into new vulnerabilities tomorrow, so staying updated with emerging security trends remains a key responsibility. Aspiring IT experts must integrate the OSI model knowledge into their academic studies and real-world testing, ensuring all systems they design or maintain adhere to robust security standards. The OSI model not only serves as a guiding framework for understanding network communication, but also stands as a foundation for securing digital infrastructures. By recognizing the distinct security concerns of each layer and implementing defenses holistically, you as IT students can contribute to creating a safer cyber environment. Remember, a secure network doesn't rely on a single layer, but on coordinated defenses across all 7 layers. So build your expertise carefully, think critically, and apply these strategies in both your academic work and future career.
Thank you for